Good day, Dr. Shabil. My name is Choong Kai Wen from class APW375 Logistic Management. Today, I will present about my title, which is Sustainable and Environmental Logistic Management in the Industry 4.0 era. Logistics is a key driver of the economic growth, but climate change now demands greener operations. In the Industry 4.0 era, technologies like Internet of Things, AI, Big Data, and so on help logistics save energy usage, reduce emissions, and improve resources efficiency. In global initiatives, US, Japan, and Europe are promoting green and smart logistics like using electric vehicles, route optimization, and smart warehouse. Even though Industry 4.0 can make logistics more sustainable, but companies face challenges like high technologicals, lack of digital skills, cybersecurity risks, and the old systems slow down adoption. As a result, many logistics organizations struggle to fully achieve environmental goals and implement green performance in organization. The objectives are: first, to identify the key Industry 4.0 technologies. Second, to evaluate the advantage and disadvantage that are faced by the logistics industry via framework. Third, to evaluate the framework by using it in the logistics industry. And lastly, to propose strategies and recommendations through framework. Our research questions are: first, what type of the Industry 4.0 that influence the transformation of the logistics industry? Second, how does sustainable logistics technologies adoption in the Industry 4.0 influence logistics performance? Third, which strategy to be developed to overcome and to reach the goals of the sustainable and environmental logistics management in the Industry 4.0 era? In the literature review, we have three main focus. Firstly, sustainable warehouse use Industry 4.0 technologies like IoT, automation and robotics, UAVs, and digital twins to reduce waste, energy use, and carbon emissions. These tools improve storage efficiency, lower operating costs, and support environment goals. Although high investment and technical skills are challenges, sustainable warehouse is essential for greener logistics in the Industry 4.0 era. Secondly, green and environment logistics. It reduces the environmental impact of transport, storage, and distribution. With Industry 4.0, companies can use electric vehicles, route optimization, eco-packaging, and renewable energy to lower carbon emissions. Supported by policies and technologies, green logistics allows organizations to operate efficiently while meeting sustainable and environmental compliance. Thirdly, AI supports sustainable logistics by improving demand forecasting, automated warehouse, smart routing, and real-time visibility. It lowers energy consumption, energy waste, and improves eco-efficiency. However, challenges still exist, including integration with legacy systems and cybersecurity risks. Overall, AI is a key driver for sustainable logistics in the Industry 4.0 era, but requires strategic adoption. Firstly, this framework illustrates how Industry 4.0 technologies such as IoT, robotics, AI, and automation enhance warehouse sustainability across three pillars: economy, social, and environmental. However, it is still idealistic that real-life complexity is not fully shown. It involves external forces like policy, budget, and infrastructure, and no feedback loops that only assume positive feedback. Secondly, this framework shows how Industry 4.0 technologies improve warehouse operation and support sustainability. Digital tools enhance accuracy, speed, visibility, safety, and efficiency, which leads to economy, environmental, and social benefits and supports the UN Sustainable Development Goals (SDG). However, in the study found out that it focused mainly on economic outcomes with limited real-world evidence for environmental and social impacts, and it does not fully consider cost, richness, and workforce challenges. Thirdly, this framework explains how internal environmental communication drives the adoption of green inbound logistics practice. Communication has a direct effect and an indirect effect through organizational environmental governance, which acts as a mediator by translating messages into policies and controls. However, the model is linear and limited to three variables: ignores external, technological, supplier factors, and does not include moderating variables, which reduce its explanatory depth. Fourthly, this framework shows how AI and big data analytics in Industry 4.0 promote environmentally sustainable growth. The technologies drive eco-friendly development, which improves sustainability and support economic growth and stability, and highlights the strong link between. However, the framework focuses on a specific context, ignores social, legal, and cultural factors, use terms that may vary across organizations, and relies mainly on economic stability, overlooking other important parts to sustainability. Followed by this framework shows how Industry 4.0 transformed logistics centuries into logistics century 4.0 by linking 12 key competencies like handling, information, transportation, and warehouse management. It maps how these competencies interact, providing a roadmap for advanced logistic operations. However, it relies on expert judgment, may not fit all regions, overlooks human and organization factors, and needs updates as technology evolves. In this framework shows how logistic innovation reduces supply chain risk across three areas: company side, customer side, and environmental risk. Logistic innovation through new technologies, processes, or services can help to reduce uncertainties across all three risk areas. However, it treats innovation as a single concept and excludes other risks like cybersecurity and financial issues. Ignores moderating factors such as organizational capability or digital readiness, and is mainly conceptual, which limiting practical applicability. The framework shows that artificial intelligence usage improves logistic efficiency both directly and indirectly through last-mile logistics and supply chain consistency. Thus, a coordination and collaboration moderates the impact across logistic players. However, it treats AI as a single variable, generalizes the mediators, considered collaboration only as a moderator, and ignores external factors like environmental, infrastructure, or market conditions. Continued by this framework shows how low carbon logistics and low carbon tourism directly support economic growth, while technological innovation and renewable energy as mediators that enhance their effects. So the TI and RE reinforce each other and improve the efficiency of LL and LT, with economic benefits increasing once certain thresholds are reached. However, the framework relies on provision level data, does not consider transition costs, and may have limited applicability in other countries. Lastly, this framework explains green warehousing using stakeholder theory like employee participation, top management commitment, and owner support, together with institutional theories from governance pressure, industry competition, and consumer demand, drive the adoption of green warehouse practice. However, it assumes all factors are positive, does not show interaction or barriers, focus on a limited set of criteria, and exclude factors like technology, cost, and organization culture that making it less comprehensive. We have 6 independent variables to focus. Firstly, IoT allows real-time monitoring of vehicles, warehouses, and inventory through sensors and tracking devices. It helps companies to plan delivery routes more efficiently, reduce fuel consumption, and predict maintenance issues early. As a result, IoT reduces operational waste and carbon emissions while improving overall logistic efficiency. Secondly, robotics automate vehicles and drones improve logistics by automating tasks such as picking, sorting, and inventory management. These technologies reduce human error, increase productivity, and improve energy efficiency. Overall, they support faster, safer, and more sustainable logistic operation. Thirdly, artificial intelligence AI enhance logistics by using data to support better decision making. AI predict customer demand, optimize inventory level, and improve production planning. This can help to reduce waste, increase efficiency, and create a safer and greener logistic operations. Fourthly, blockchain improves logistics sustainability by increasing transparency and traceability in the supply chain. It allows companies to track products' origins, carbon emission, and ethical sourcing. This helps ensure responsible practice and supports sustainability reporting and compliance. Continued by the Cyber Physical System (CPS). It integrates physical logistic operations with digital control system. They enable real-time monitoring, automation, and optimization of warehouse and transport. This can reduce energy consumption, downtime, and waste, leading to more sustainable logistic performance. Lastly, big data analytics helps logistic companies analyze large volumes of data to identify trends and improve decision making. It enhances demand forecasting, reduces overproduction, and optimizes transportation and resources use. This result is cost saving and greener logistic operation. Now we move to the mediator that have 4 elements. Firstly, technology readiness refers to how prepared an organization is to adopt digital technologies. It includes infrastructure, technical skills, and management support. High readiness allows smooth technology implementation and strengthens the positive impact of digital tools on logistics sustainability. Secondly, green supply chain collaboration involves collaborations between logistic firms, suppliers, and customers to achieve sustainability goals. By sharing green practice and information, organizations improve waste management, environmental compliance, and the effectiveness of digital technologies. Thirdly, circular economy practice focus on reducing waste through reuse, recycling, and remanufacturing. Digital technologies such as IoT, AI, and blockchain support reverse logistics and resources recovery. This connects technology adoption with real environmental benefits. Lastly, eco-friendly development reflects an organization's commitment to reducing environmental impact while supporting long-term growth. It includes lowering emissions, improving energy efficiency, and adoption green logistics system. Digital technologies help ensure that this innovation leads to sustainable outcomes. In the moderator, first, organizational support refers to how well a company supports our use of Industry 4.0 technologies through management commitments, skilled staff, training, budget, and policies. When organizational support is strong, technologies such as AI, IoT, and automation can be used more effectively. However, when organizational support is weak, the sustainability benefits of these technologies are reduced. Second, environmental dynamism describes how fast changes occur in the business environment, such as customer demand, competition, or regulations. In highly dynamic environments, adopting digital technologies has a stronger impact on sustainability practice. In more stable environments, the impact will become more bigger. Therefore, environmental dynamism highlights the importance of quick and timely response to achieve sustainable logistic performance. Lastly, dependence variable, which is a logistic performance in Industry 4.0, refers to improvement in speed, accuracy, efficiencies, and sustainability through technologies such as IoT, AI, robotics, blockchain, CPS, and big data analytics. These technologies help reduce waste, improve resource reuse, and optimize logistic operations. With the support of technology readiness, green collaboration, eco-friendly development, organizational support, and environmental dynamism, companies can achieve higher and more sustainable logistic performance. In the conclusion, the recommendation framework shows that sustainable logistic technologies such as IoT, AI, robotics, automation, and so on can significantly improve logistic performance in the Industry 4.0 era. These technologies enhance real-time visibility, efficiency, and data accuracy. However, technology alone is not enough. Its impact is strengthened through mediators like technology readiness, green supply chain collaboration, circular economy practice, and eco-friendly development. At the same time, strong organizational support and environmental dynamism further enhance these effects. When technology green practice and organizational capability work together, logistic performance becomes more efficient, sustainable, and competitive in the long term. This is the end of my presentation. Thank you for listening and watching.